We have to find the combination x1 multiplying column vector w1 is 2 multiplying column vector w2 and x3 w3 that gives a zero vector, meaning okay, let's translate that into the equation. So x1 times 1 2 3 plus x2 times 4 5 6 plus x3 times 7 8 9, and this has to equal zero vector meaning 0 0 0. Okay, so now we can distribute the x1 in each one of the column elements. So we get x1 2x1 3x1 for the first column vector, plus similarly here 4x2 5x2 6x2 plus 7x3 8x3 9x3, and that has to equal 0 0 0. Okay, so now we can add the corresponding cells and we will get three equations. So x1, so I'm adding this row that has to equal 0, so x1 plus 4x2 plus 7x3 equals 0, 2x1 plus 5x2 second row plus 8x3 that has to equal 0, and 3x1 plus 6x2. These are three equations and three unknowns. Let's try to solve them. We could use elimination or substitution, whatever. I could take the first two equations, multiply the first one by minus 2 to eliminate x1, and if I do that I get minus 2x1. So I'm multiplying equation 1 by minus 2, minus 8x2 minus 14x3 equals 0. Leave the second equation as is, and then I will add the two equations, and so these guys go away and I get minus 3x2 minus 6x3 equals 0. And now I could also eliminate x1 from the next two equations. So let's use this color here. So I could take both of these equations, multiply the first one by 3, or multiply the first one by 3 and the second one by minus 2. So I would eliminate, because I would get 6x1 minus 6x1. So let's do this here on the side. So the first equation becomes 6x1 plus 15x2 plus 24x3 equals 0. And then the third equation becomes minus 6x1 minus 12x2 minus 18x3 equals 0. And now I will add these two equations. These guys go away. Get minus 3x2 or plus 3x2. 24 minus 18 is 6x3 equals 0. And now I can see that the x3s have the same but opposite sign coefficients, so they're ready to go. And I can add both of these equations. But we got sort of an issue here, because these two equations will cancel out. I will get 3x2 plus 6x3 equals 0, and if I add them they both cancel out, which tells me 0 equals 0. That tells me that this system is an independent system. Meaning to solve this system I could, for example, choose x1 to equal 1, and if I do that to get a non-zero solution for this, I would get, so plug this in the first equation, I would get, so let's change the color here, 4x2 plus 7x3. So here I conclude that this is a dependent system. Means there's an infinite amount of solutions. Okay, so 4x2 plus 7x3 would equal minus x1, which is minus 1, and the second equation would get me 5x2, or let me use the third equation, it's better. So 6x2, yeah, and the third equation is 6x2 plus 9x3 equal minus 3x1, meaning minus 3, because I chose x1, so choose x1 to equal 1. Okay, and I can solve the system here. I could multiply, let's see, I could multiply the first equation by 3 or minus 3, and the second equation by plus 2 to get rid of the x2. So I would get on the first equation minus 12x2 minus 21 x3 equal 3, and multiplying the second equation by 2, I would get 12x2 plus 18x3 equal minus 6, and now I would add the two equations, these go away, and we will get minus 3x3 equal minus 3. So that means that x3 equals 1. So now that I picked a value for x1, I was able to determine x3, and I can plug in the first equation to find x2 in any one of the equations. Let's plug it in this equation here. So 4x2, before I pre-multiplied it by minus 3, so I would get minus 1 minus 7x3, and x3 is 1. So this would get me 4x2 equal minus 8, which makes x2 minus 2. So therefore the combination that gives me a 0 vector, one of the combinations that gives me a 0 vector, is x1 being 1 times the first vector 1 2 3 minus 2, x2 is minus 2 times 4 5 6, and then x3 is 1 plus 1 times 7 8 9, and this is guaranteed to give me a 0 vector. Of course, there's an infinite amount of combinations according to what we've just been through, that the system is dependent, meaning every time you assign let me remove this box, it's kind of ugly here. Let me see if I can make it nicer. Okay, not bad. So meaning the system is dependent, every time I assign a value for either one of the variables, I could find the others. So so the vectors are dependent, the fact that that's what we determined here, and they do lie in the plane. The matrix W with those columns is non-invertible, meaning you can't find an inverse, because this is a dependent system. It's singular. If you were to go find the determinant of the system, you will get a 0, meaning that the matrix is not invertible. It doesn't have an inverse. That does it.